So in this video, we're going to look at two examples. With these two examples, they're going to involve this new theorem called the fundamental counting principle. It's something you saw in Math 211. We're just going to extend it to apply to Math 212. So the fundamental counting principle says that if you have events that occur m and n ways, in this case 2 events, that if they are in a certain sequence, you can multiply the total number of outcomes to find the total number for the experiment. Makes more sense if we see an example. So with that being said, let's jump into example 1. The access code for a car security system consists of 4 digits. Each digit can be 0 to 9. How many access codes are possible if, letter A, the digit can only be used once? So the first thing, I have this random 4-digit code. Each digit can be 0 to 9, 0 to 9, 0 to 9, 0 to 9. So there are 10 numbers between 0 to 9 because there's 1, 2, 3, 4, 5, 6, 7, 8. There's 9 of those, and then plus 1 for 0. So in this first one, each digit can only be used once. Well, I still have the same 4-digit code. The first one, there's 10 possible digits, 0 to 9 numbers. However, because whatever number I picked first, I can't use in the second one. Now, the second digit, there's only 9 possibilities because I just used one. The third digit, there's only 8 possibilities because now I've used 2 numbers. And then the last one, there's only 7 digits because I've used all the other numbers above that haven't been repeated. If you multiply all those, you get 5,040 codes that could be made with that stipulation. Now the next one says each digit could be repeated. So I've got my 4-digit code. There's 10 digits that could go first. Because they can be repeated, 10 digits that can go second, 10 that can go third, and 10 that could go fourth. And so for this one, if I allow for repeats, there are 10,000 possible codes. And then the last one, each digit can be repeated, but the first digit cannot be 0 or 1. And so for whatever reason, they've said the first digit can be 2, 3, all the way to 9. And so there's 8 of those numbers. Then they don't care about the rest of the digits. They can be repeated. They can be 0 to 9. And so there's 10 of those. And so this one has 8,000 possible codes. Next example. Early in the morning, you're groggy. You have to select something to wear for your 8 a.m. class. Your wardrobe is limited because you haven't done laundry. You have 2 pairs of jeans, black and blue, 3 t-shirts, and 2 pairs of shoes. So we're going to assume that everything matches, or you don't care, whichever. And that's really, we're assuming that everything matches. So you're randomly grabbing stuff. So the first thing it says is how many possible outfits can you choose? Use a tree diagram and the fundamental counting principle. So first, let's make our tree diagram. I've got an extra sheet of paper down here just because it's going to run out of room in that little tiny space. So the first line I need to do is my pants. So in my problem, the pants I have are, or jeans, black or blue are my options. So of my pants, I've got black pants or blue pants. The next one that I can choose from is going to be my shirts. And so the shirts I have are going to be white, green, or red. Those are my only options. So I've got black pants, but I could wear a white shirt. I could wear a green shirt, or I could wear a red shirt. Same thing over here. I could do white, green, or red. And then with my shoes, so we've got shirts, we're next, and then shoes. With my shoes, I've got 2 pairs. It says black or brown. And so here I could have black or brown, black or brown, all the way around. So this is how we learned to do it technically back in the last section. And then we kind of practiced this tree diagram. And so all the possible outcomes I could have: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I get the answer of 12. However, a shortcut to that is going to be using the fundamental counting principle, which says you can multiply jeans times shirts times shoes. So shoes, I had 2 of them. Shirts, I had 3, and jeans, I have 2. And so when I multiply all of those together, I get out 12 possible outfits, which is what I saw in the tree diagram. But now we're just looking for shortcuts, because as these examples get bigger, like in the next one, you're not going to want to draw all of this stuff out. So in the next example, now you've done laundry, and you have 8 pairs of jeans, 21 shirts, and 6 pairs of shoes. Now, how many outfits do you have? You would not want to do a tree diagram for this. It would take up an entire poster board, writing really small. I'm going to use the same formula, if you will. So I'm just going to copy and paste this. Jeans times shirts times shoes. Well, in this case, my jeans, I've got 8 pairs of jeans times shirts. I've got 21 shirts. And then shoes, again, we're assuming everything matches. 6 pairs of shoes. So the fundamental counting principle says that you can multiply them and get out 1,008 outfits. And so now you don't have to bother with the tree diagram. We can use this fundamental counting principle. This just finds the total number of outcomes. It doesn't necessarily find the probabilities in the middle, but it certainly is beneficial.